Okay, so that gives me my confidence interval, and that is what we were asked to calculate. We good with that? Okay. All right. So now let's look at hypothesis test. So here is going to be a t-test for slope. So just like what we did with the other tests that we looked at, like when we were looking at means, we use x bar to represent the sample mean, and then we use mu to represent the population mean. We use here b represents the sample slope, and then we use the Greek letter beta, which looks like a B, but it has a tail on it. So beta represents the population slope. And so we always have equal sign on the null and then some sort of inequality on the alternative. Almost always we're going to be testing against the value 0, because 0 means there is no relationship. It's not linear. Okay? Anything other than that shows us it's either positive or it's negative. So there's some relationship and we can see which direction it goes, then that's enough for us to say there is some sort of relationship. Okay? Now, like I say, typically it's 0, but there have been cases, I talked to you guys last week, I think it was, about question 6. And sometimes they throw something weird in there. A few years ago there was a question 6 where they asked you to test, is the slope 1? And you had to put beta equals 1 instead of 0. So sometimes that can show up, especially on a question 6. If it does, everything else works exactly the same. It's just you have a 1 instead of a 0. So don't get worried about it. Just do what you're supposed to do. On this one, we're just seeing, is there a relationship? We're not looking for, is it a positive relationship? In which case we would say greater than 1, or greater than 0 here. If it were a negative relationship, we'd say less than 0. But here we're just looking for, is there any kind of relationship? So we're just saying not equal to 0. So our beta is the true slope of the equation for the relationship between, and this is where we would just say our x and y variables in context. So here our x variable was anxiety level. And the y variable was math test. We're just wanting to know, are these things related? For our do the math, the equation looks very much like what we did for the other test, for the other t-test. For our t-test for means, we have the sample mean minus the population mean, so x bar minus mu. Now we have the sample slope, which is b, minus the population slope, which is beta, all over the standard deviation, which is standard error for b. So if we plug in the values, our sample slope was negative 4.49 minus our beta. Now we don't know for sure what it is because we're testing to see which one it is, but until we've proven otherwise, we assume HO is true. So we're going to say beta is 0. until we can say it's not. Our standard error was 1.55. And so when we compute that, that is our t-test statistic. So when we subtract 0, we just get negative 4.49 on top divided by 1.55. So that gives us negative 2.8968. Now, if we look back at our computer output at the top, this negative 2.8968, you'll notice is right there. That's the t-test statistic. So when you're calculating it, it should match what you have in your output. So what do you think would be the p-value? Yeah, right there. Well, they will ask you sometimes show the calculation for getting the test statistic or something. So you need to know how to do it, but a lot of times if they just ask you what would be your decision, you're going to base it on the p-value. Any other questions on this side of the page? Okay, look at the other side. So these are some multiple choice questions. Often these are asked in a multiple choice situation. So I want to work through a couple of these with you to show you how I would do this question. So here we're looking at the body weight in kilograms and brain weight in grams of 22 non-human mammals. We're looking at the linear regression analysis here, and they want to know if all the conditions are met, just assuming that's taken care of, which of the following expressions represents a 95% confidence interval, so that's what we're looking for the slope of the least square regression equation. So I know to calculate this is going to be that b plus or minus the t times standard error of b. That's my formula. That's what these should be written in this form. So I should be able to look at these equations and see what do they think is b, what do they think is my test or my critical value, and what do they think is this standard error. So these two I can get from right up here. So my slope should be what? There we go. Right there is b. So this should be 1.096. So just from knowing that, I know that E is not a correct answer because that is not the slope that they put in that place. All the others have that number, so the rest of them are still a possibility. What is my standard error? Right. So this should be the number at the end, and I have this critical value in between there. So when I look through just this last part in each one, now I can see this A is the only one that has the correct value for standard error. So that means this is my decision. It's going to be A. So without having to take time to look up that T critical value, I can eliminate enough choices that I know the answer. So on a multiple choice, on a time test, I would do things like that. Do the quick ones first, and then if there were still a couple of them that match, then you could go back and look at the critical value. We good there? Mm-hmm. All right, let's look at the other one. So this one, looking at a random sample of 12 students in their major field of study. They were asked how many hours they spent studying for the final exam and their score on the final exam. And they did this analysis. They want a 95% confidence interval, and we're just concerned with margin of error. So if we're looking at this formula for a confidence interval, what did I put a C? That's kind of a crazy looking SE, but you know what? It's good. Which part of this equation gives me margin of error? So that part right there is margin of error. Everything after the plus or minus. So that's my margin of error. So that's what I'm plugging into. So, so we want the t, which all of these are the same, so we don't have to look that up. Standard error, we're going to look up here and see our standard error is 0.745. So that's going to tell me which one is correct, because these are all different. So again, we have choice A. Is this making sense to you guys? Yeah. Okay. Alright. Number 3 says, look back at this problem. So we're still working with the numbers from problem 2. And we want to know, is there a linear relationship? Not relationship. Between the number of hours spent studying for the final exam and the score on the final exam. And we want to justify our answer. So, what number do we use to make our decision about a value? Think of step 5. You have your 6-step process and a hypothesis step. Step 5 is make a decision. So, how do we do that? Yeah, we're comparing p-value and alpha. Can I look up here and tell what the p-value is? What is it? Right here. So we look on this line that has study hours, so the one that's not the constant. This is our x line, so this is our slope. This is our standard error of slope. Here's my p-value for slope. So that's going to let me make a decision, because I know it's a 95% confidence level, so that means alpha is what? 0.05. So if 95% is in the interval, then that leaves 5% outside for the error. Okay? So alpha 0.05, or p-value 0.005, so it's less than. So what is my decision? Oh, wait. Don't do anything. Isaac, what's my decision?
Decision?
Do I reject or not reject?
You refuse, you reject.
Reject. So, we have evidence or we do not have evidence? We have evidence. So, and right here is my conclusion. There's evidence of a significant linear relationship between the number of hours spent studying for the final exam and the score on the final exam. That's my conclusion. So there is evidence of all that. This is going to go on page 113 in your notebook, so make sure that gets attached. You have problem set 70 and 71, so those you should be able to do. from what we've done. Most of it's just multiple choice. You're just writing it in, doing just what we did on these first two multiple choice. But there is some that you're going to have to answer for interpreting different things and all that.